Hello, my dear students. My name is Lakshmi Narayana. This is LN Brand of Chemistry channel. So today we are going to discuss redox reaction chapter in that oxidation number and oxidation state. Oxidation number or oxidation state. So chapter name is redox reactions. In the redox reactions, the first topic is oxidation state or oxidation number. So now such type of questions in the JEE mains examination or in the NEET examination, such type of questions they are asking. Which type of questions? What is the oxidation state of sulfur in H2SO5? Then what is the oxidation state of bromine in Br3O8? Then what is the oxidation state of chlorine in CaOCl2? So chlorine oxidation state in CaOCl2. ఇలాంటి క్వశ్చన్ అడుగుతాం. So generally the many of the students, they know the formula how to find out the oxidation state. By using that formula, by using that concept, they did many mistakes. For example, here if you take, sir, hydrogen, then a sulfur oxidation state you have to find out. So that you have to take as X. Sir, ఇది అందరికి తెలిసిన విషయం. So the two hydrogen atoms కి 2, then plus X, then minus each oxidation state minus 2 into 5 minus 10, then equals to 0, then X equals to 10 minus 2, then equals to 8. So 8 is the oxidation state. We'll discuss. But actually, sir, plus 8 oxidation state for the sulfur atom is wrong. Because sulfur highest oxidation state plus 3 or plus 6 only. So group number is the highest oxidation state for any element. Then if you come to here, sir, here 3x bromine oxidation state if you want to find out 3x. Sir, minus then 16 equals to 0. Then from this you can get x equals to 16 divided by 3. So that is the answer. But actually this is wrong answer for me. So then what is the chlorine oxidation state in case if you take here? So chlorine oxidation state. Sir, Ca plus 2 oxidation state. Then this is minus 2 oxidation state. Then this is X, so that you have to find out. So plus 2 minus 2 then plus X equals to 0, then X equals to 0, right? So 0 oxidation state in the chlorine in case if you do this concept. సరే ఇలా ఫార్ములా యూజ్ చేసి కనుక మనం ఆక్సిడేషన్ స్టేట్ ఫైండ్ అవుట్ చేయాలనుకుంటే సరే ఇలాంటి ప్రాబ్లమ్స్కి అది రాంగ్ అవుతుంది. దెన్ వాట్ వీ హ్యావ్ టు డూ? సార్ మరి ఇది ఎలా చేయాలి? సార్ ఆక్సిడేషన్ స్టేట్ కరెక్ట్గా ఫైండ్ అవుట్ చేయాలంటే సార్ ఏం చేయాలి అంటే సార్ యాక్చువల్లీ ద స్ట్రక్చర్ ఓన్లీ ఈజ్ అ కరెక్ట్ స్ట్రక్చర్ ఓన్లీ క్యాన్ గివ్ కరెక్ట్ ఆక్సిడేషన్ స్టేట్ ఫర్ ఎనీ ఎలిమెంట్. Structure only can give correct oxidation state for any element. So first of all, oxidation state and oxidation number we have to discuss. So what is the oxidation state and what is the oxidation number? Formal charge which an atom has in a molecule or ion is called oxidation state. Oxidation state or oxidation number we call. So for example, if you take H2SO4, so first one we are taking H2SO4, sulfur oxidation state in H2SO4. Sulfur oxidation state in H2SO4 in case if you take. Sir, you have to take the structure of H2SO4. Yes, then double bond O, then double bond O, then OH, bond H, then O, bond H. Sir, oxidation state find out cheyali. Oxidation state find out చేయాలంటే సరే ఏం చేయాలి ఫస్ట్? Sir, I will tell one of the example to you. Sir, in case one of the molecule like AB is there, A bond B ఉంది. Sir, in between A bond B, sir, covalent bond is there. Which bond is there? Covalent bond. So this is more electronegative atom then this is less electronegative atom. Less electronegative atom. Sir, more electronegative atom mida -1, you have to represent -1. This is +1. +1 you have to represent. So remember, oxidation state ela represent cheyali ante in a covalent bond. So you have to give -1 for more oxidation state, +1 for less oxidation state. So note that in covalent bond, for more electronegative atom, -1 oxidation state, and less electronegative atom, for less electronegative atom, +1 oxidation state we have to represent. +1 oxidation state, that you have to remember. So generally how to remember the order of electronegativity? Then fluorine is the highest electronegative, then after oxygen, then after nitrogen, so then after chlorine, so that you have to remember. So chlorine, so actually chlorine and nitrogen and chlorine both are having the same electronegativity, but you have to give according to the scale, that is you have to give nitrogen is the highest oxidation state. Clear, my dear students? Right. So now if you take in this molecule, sir, in between the first sulfur and oxygen atoms, sir, ikkada covalent bonds unnai, 2 covalent bonds unnai. Sir, 1 covalent bond in case if you take, this is -1, then +1. Then in this side, even this is -1, then +1. Then downside also 2 bonds are there. Sir, one is -1, then +1. Endukani? More oxygen, more electronegative is oxygen than that of sulfur. Sulfur kante oxygen more electronegative kabatti దీనిపైన -1 oxidation state, దీనిపైన +1 oxidation state ఉంచాలి. Sir, again it side bond ki -1, then +1. So look at even here also sulfur oxygen, then -1, then +1, then here -1, then +1. So totally how many positive charges you can get? It is +6. So sulfur oxidation state is +6. +6 is the answer for this. Clear, my dear students? So sulfur oxidation state is +6. Then in case one more molecule, that is, sir, H2S, if you take H2S, sulfur in H2S, if you take, sir, sulfur, then hydrogen atom, sulfur in between covalent bond is there, sulfur and hydrogen atom in between covalent bond is there. More electronegative atom, sulfur is the more electronegative, -1, then hydrogen +1, then here +1, then here -1. So sulfur oxidation state in the H2S, sulfur oxidation state in the H2S is then -2. -2 is the oxidation state. -2 is the oxidation state. So you have to identify the oxidation state by using this concept. Sir, oka bond, oka covalent bond lo oxidation state ni ela represent chesta unnamante, more electronegative atom ki -1 ani, less electronegative atom ki +1 ani represent chesta unnam. So now, so one more example we'll see, that is KMnO4. Manganese oxidation state in KMnO4. Manganese oxidation state in KMnO4. Sir, manganese oxidation state, if you want to find out, the structure of KMnO4 should be known. So that is manganese, then double bond O, then double bond O, then double bond O, then single bond O minus K plus, like this will be the actual. Okay, clear, my dear students? So now in between the manganese and oxygen, one of the bond is there, that is a covalent bond. So here -1, then +1. Here 2 bonds are there, 2 covalent bonds. Sir, which is the most electronegative? Oxygen is the most electronegative atom. So -2, then +2. Then here also -2, then +2. then here also -2, then +2. So totally positive charge, how much is there surrounding of nitrogen and manganese atom? So +2, +2, +2, +6, then +1, +7. So manganese oxidation state is +7. +7 is the manganese oxidation state. Then in case if you take phosphorus oxidation state in H3PO4, H3PO3, H3, then PO2, then PH3. Sir, if you take oxidation states of all these, right? So one by one structures if you take, sir, H3PO4 first we are taking phosphorus, then look at my dear students, then double bond O, then O bond H, then O bond H, then O bond H, like this will be there. H3PO4 it is. So look at H3PO4, PO4. So now in between phosphorus and oxygen, double bond is there. Oxygen is the most electronegative, -2. Then for this +2. This is -1. For this +1. This is -1. For this +1. This is -1. For this +1. So total positive charge surrounded by phosphorus is +5. So in H3PO4, phosphorus oxidation state is +5. Clear, my dear students? Then one more, if you take H3PO3. Sir, actual structure of H3PO3, then P double bond O, then OH, then OH, then H directly it is attached. So now look at in between phosphorus and oxygen double bond is there, then -2 oxidation state here, then +2 oxidation state. Then come to there, here -1 oxidation state, then +1 oxidation state. Here -1 oxidation state, then +1 oxidation state. Then come to there itself, phosphorus and hydrogen if you take both. Phosphorus get +1, hydrogen get +1, phosphorus get -1 oxidation state. So then -1 no +1 both will be cancelled, then +1 and +2. So totally +1 and +2 only will be there. Then that is +3 oxidation states surrounded by that. Clear, my dear students? Then if you come to H3PO2, sir, phosphorus double bond O, then O bond H, then 2 hydrogen atoms directly attached to the phosphorus. So now oxygen in between phosphorus, if you take -2 +2 oxidation state, then here hydrogen can get +1 oxidation state, then phosphorus can get -1 oxidation state. So then even here also +1 oxidation state, -1 oxidation state. Then here -1 oxidation state, +1 oxidation state. So once +1 -1 cancel, then +2 -1, then +1 oxidation state will be present in it, +1 oxidation state. Here +3 oxidation state. Sir, what about the PH3? Sir, look at phosphorus attached with 3 hydrogen atoms like this. Then now in between the phosphorus and hydrogen, sir, hydrogen is the electropositive and phosphorus is electronegative. So -1 +1, then +1 -1, then +1 -1. Totally -3 is the oxidation state of this, -3. So look, my dear students, the phosphorus oxidation state, it can exhibit the different oxidation states like this, +5, then +3, then +1 and -3. So like this. Note it all of you. Then we'll see some more questions. Yes. So next, in case if you take in the elemental state like nitrogen, N2, oxygen, O2, chlorine, Cl2, bromine, Br2, right? Then P4, phosphorus, P4 phosphorus. So like this if you take. So what are those I told? Sir, in case nitrogen in N2 molecule, chlorine in Cl2 molecule, oxygen in O2 molecule, phosphorus in P4 molecule, like this they are mentioned. So look at what is the actual structure of N2. Sir, N triple bond N. Right. So now electronegativity difference in between the nitrogen atoms are 0, right? So 0. So oxidation state of N2 molecule is 0. Then in case chlorine, if you take chlorine bond chlorine, then 0, 0, oxidation state is 0. So next oxygen, in between oxygen double bond is there. Sir, both are covalent bonds only. Sir, electronegativity difference in between them 0, 0. So oxidation state is 0. Sir, phosphorus P4, if you take phosphorus, the P4 it can be exhibit like this. So it is the actual structure of P4. Then in between the phosphorus 0, 0. Phosphorus 0, 0. Then 0, 0, 0, 0, 0, 0, totally 0. Clear, my dear students? So what it is understand in case when it is present in the elemental state. Sir, in elemental form, oxidation state is 0. Oxidation state 0 ఉంటుంది elemental form లో. సరే ఏవైనా ఉండొచ్చు. సరే F2, then Br2, then yes. So when it is present in the elemental state, that exhibit even S8, sulfur S8 oxidation state is 0. Sulfur atom oxidation state is 0. So these are the oxidation states are 0. Then next, so any atom when it is present in the elemental state, oxidation state is 0, we are discussing. Then some more molecules we'll see. Oxidation state of nitrogen in NO2. Oxidation state of nitrogen in NO2 molecule. Right? Oxidation state of carbon in CO2 molecule. Then oxidation state of carbon in CCl4 molecule. Oxidation state of carbon in CCl4 molecule. Then oxidation state of nitrogen in NH3 molecule. If you take, so you have to take the structure, original structures. If you take, then you can identify easily. Sir, here NO2 is there. Sir, NO2, N, then double bond O, then double bond O, like this will be there. Sir, -2 oxidation state, +2, then -2, then +2. So totally nitrogen surrounded by +4 oxidation state is there, +4 is the oxidation state. Then carbon double bond O, then double bond O. So -2 oxidation state, +2, then -2, then +2. Total positive charge surrounded by the carbon is +4. So +4 is the oxidation state for this. Then carbon tetrachloride, if you take carbon surrounded by the carbon atom, 4 chlorine atoms are there. Sir, chlorine is the most electronegative than that of carbon, right? So -1 oxidation state, +1 oxidation state. -1, then +1, -1, then +1, then -1, then +1 oxidation state. So total positive charge surrounded by the carbon atom is +4. +4 is the oxidation state. So nitrogen oxidation state in NH3 molecule, in case if you take nitrogen oxidation state, NH3 molecule. So 3 hydrogen atoms are there. This is -1, then +1, -1, +1, -1. Total charge on the nitrogen atom is -3. -3 is the oxidation state. So like this, the structure only can give 100% oxidation state. That you have to remember. Structure only can give 100% oxidation state. So then some exceptional cases also you have to see. So, such as, for example, Na2S4O6. So in that sulfur oxidation state. Oxidation state of sulfur in Na2S4O6. Oxidation state of sulfur in Na2S4O6 లేదా H2S4O6 తీసుకున్నా ఓకే. సరే, ఇందులో సల్ఫర్ ఆక్సిడేషన్ స్టేట్ ఫైండ్ అవుట్ చేయాలి. Sir, I told that in case if you take formula, then may be wrong. But 100% correct oxidation state can given by only the structure. Structure only can give 100% oxidation state. That's what I told. This structure, in case if you take, sir, sulfur, then sulfur, then sulfur, then sulfur, then double bond O, then double bond O, then bond O, sir, H, bond H, then double bond O, then double bond O, then bond O, H, like this will be there. Actual original structure is this. So look at, my dear students, now. Then -2 oxidation state here, then +2 oxidation state, then -2, then +2, then -1, +1. Surrounded by this is +5 oxidation state. Then if you come to there, sulfur, sulfur, in between bond is there. Electronegativity difference is 0, we know that for this bond. Then even here 0. Then even here 0 for this. Then if you come to sulfur and oxygen here, -1 +1, -2 +2, -2 +2. Total positive charge is +5. So, sir, actually original correct answer for the oxidation state of sulfur, sir, one is +5, then +5, then 0 for the second atom, third atom 0, then fourth atom again +5. Sir, average oxidation state, in case if you want to find out average oxidation state, they will ask a question in that. What is the sulfur average oxidation state in H2S4O6? If they will ask, then you have to take all the oxidation states like this. Sir, what are those? +5, then +0, +0, +5, then divided by how many atoms are there? 4 atoms. So then 10 divided by 4, then you can get 5 divided by 2. So this is the average oxidation state we call. Understand, my dear students? Then one more example, oxidation state of bromine in Br3O8. This is the molecule Br3O8. Sir, actual original structure of Br3O8, how it will be there, you know. So Br, bond Br, bond Br, then double bond O, 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 like this will be their structure. Sir, here in between bromine and oxygen double bond is there, that is a covalent bond. -2, then +2, then -2, then +2, then -2, then +2. So total positive charge surrounded by the bromine atom is +6. Clear, my dear students? Then if you come to there, -2, +2, then -2, +2, then surrounded by this is +4 oxidation state. Then what about this? -2, -2, -2, +6. So +6 oxidation state here. Clear? So +6 oxidation state. So average oxidation state, in case if you want to find out, sir, what you have to take? Average oxidation state is equals to what I told, 6 plus, then 4 plus, then 6, 12 plus 4, 12 plus 4 divided by 3. So 12 plus 4, how much? 16 divided by 3. So this is the average oxidation state of bromine and this. But they will ask a question, what is the oxidation? Individually they will ask a question. So 3 oxidation states, +6, +4, +6, like that they will ask. Clear, my dear students? So note it. Then one more we'll discuss. Yes, look at oxidation state of oxygen in H2O2. Oxidation state of oxygen in H2O2. H2O2 is what? Hydrogen peroxide. Hydrogen peroxide. In the name itself it is there. Peroxide bond is there. Then oxidation state of oxygen in H2O2. We call it is hydrogen peroxide. hydrogen peroxide. So this is there in the open book structure we call peroxide structure. So actually, sir, H bond O, then bond O, then bond H, like this will be there. So we know that in between the oxygen and hydrogen covalent bond is there. Sir, oxygen is the most electronegative, -1, then +1. Then here oxygen in between 0, 0, right? Then oxygen in between, then -1, then +1. So that's what I told. Oxygen in this oxygen oxidation state is -1 in the peroxides. Sir, in the same case, oxidation state of oxygen in HO2F will be there like this. Sir, how it is? Sir, H bond O, then F will be there like this. The same structure, but in the place of one hydrogen atom, fluorine is there. Then at that case, look at now. Sir, hydrogen, oxygen, in case if you take hydrogen +1 oxidation state, then oxygen -1 oxidation state, here -1 oxidation state, then here +1 oxidation state, right? Sir, in between oxygen and fluorine, which is the most electronegative? Fluorine is the most electronegative, -1, then oxygen +1. So remember, my dear students, oxygen can exhibit. Sir, one is -2 oxidation state it can exhibit, -1 oxidation state it can exhibit, even +1 also it can exhibit, the rare case when it is attached to the fluorine. Fluorine to attach అయినప్పుడు oxygen can exhibit even +1 oxidation state also. Okay. Then two more examples we'll say, that is sulfur oxidation state in H2SO5. Sulfur oxidation state in H2SO5. Sulfur oxidation state in H2SO5. Yes, look, my dear students, then here sulfur oxidation state, if you, in case if you want to find out. So you must be the know structure of that, this we call it is actually Caros acid. Sir, here original structure of this, S double bond O, then double bond O, then O bond H, then bond O, bond H, like this will be there. So look at, sir, here -2 oxidation state, then +2, then -2, then +2, then -1, then +1, then -1, then +1. So totally how much positive charge is there? +6 is the oxidation state of sulfur. Oxidation state of sulfur is +6. So if you know the original structure, then it will be understand it. So then one more, chromium oxidation state in CrO5. So this structure actually the butterfly structure, O bond O, like this, then double bond O. So it's the butterfly, it's a butterfly structure. These two are wings, this is like a head, like this. So look at according to what concept we are discussing now. Sir, wherever the covalent bond is there, more electronegative atom -1, then less electronegative atom +1. So look at here, oxygen is there, then -2 oxidation state because of 2 bonds, then +2 surrounded by that +2. Then here -1, +1, -1, +1, -1, +1, -1, +1, plus oxidation state. So total surrounded by this +6. So chromium oxidation state +6 in CrO5 molecule. So all these, if you know the structure clearly, then only it can give 100% oxidation state. If you go through the formula, then you may mistake. We are seeing the first 3 chapter first three oxidation states of what H2SO5, then CaOCl2. So all these I told you. So that's what I told. Oxidation state, it may be difficult to find out that. So for example, the last one, in case if you take, that is CaOCl2, I told CaOCl2. So in this, if you take that formula, according to the formula, you can get chlorine oxidation state is 0. But actual structure is Ca bond Cl, then OCl, like this will be there. Sir, in between these two, which is the most electronegative? Oxygen, most electronegative, -1. Then here +1. Then in between these two, which is the most electronegative? Sir, oxygen -1. Then this is +1. If you take these two, which is the most electronegative? +1, -1. Chlorine is the most electronegative. So chlorine atom can get in this, -1 oxidation state as well as +1 oxidation state. So two oxidation states it can exhibit in CaOCl2. It is a bleaching powder formula, bleaching powder. Clear, my dear students? So now, to find out the oxidation state according to the rule, according to the formula, then what are the rules will be there, that we'll discuss now. Yes, look, my dear students, according to formula, according to structure, we are seeing. So now, in case if you use the formula, if you use the according to the calculation, so you must be know the some rules to calculate the oxidation state. Rules for calculate oxidation state. Oxidation states. Sir, what are those? What are those? So that I will discuss. First one, rule number 1, that is oxidation state of alkali metals. Oxidation state of alkali metals. Alkali metals. What are those alkali metals? First A group elements. What are those first A group elements? Lithium, sodium, potassium, rubidium, then cesium, all this. Oxidation state for this always +1 is the oxidation state. Remember, my dear students, very important. Always +1. Then oxidation state of alkaline earth metals. Earth metals, in case if we take, what are those alkaline earth metals? That are second A group elements. Second A group elements, what will be there? Beryllium, magnesium, calcium, strontium, then barium, all this. So these always +2 oxidation state. Alkali metals are +1 oxidation state. Alkaline earth metals are +2 oxidation state. So next, oxidation state of fluorine. Oxidation state of fluorine. Fluorine always -1 oxidation state. This is 100%. So the ekkada change avadu. Oxidation state of fluorine. Of course, alkali metals and alkaline earth metals also, it won't change. So because that are electropositive, this is electronegative completely. So fluorine is the most electronegative atom entire the periodic table. So that's what always -1 oxidation state. Clear, my dear students? Right. So next, oxidation state of atom in elemental form. In elemental form, nothing but, for example, nitrogen, in case if you take elemental form N2, then O2, then P4, then S8, right, Cl2, sir, Br2, then F2, sir, etc. Sir, whatever the elemental form is there, sir, oxidation state for the elemental form is 0. 0 is the oxidation state. Clear, my dear students? So alkali metals are +1, alkaline earth metals are +2 always. Then fluorine oxidation state -1. Then oxidation state of atoms in the elemental form is 0. Elemental form is 0. That are just you have to remember all these examples. Then oxidation state of oxygen. Oxygen, in case if you take oxidation state of oxygen, sorry. Yes, look, my dear students, oxidation state of oxygen. Sir, oxygen oxidation state in the normal state at a maximum case, oxygen oxidation state that can exhibit -2 oxidation state. This is a 99% is correct. -2. Then -1 also it can exhibit in the peroxide case. Peroxide అంటే ఎలా ఉంటుంది? Sir, oxygen bond like this will be present. So at that time this is -1 in case other atom will be there. Then oxygen will be there, the 0 in between them. So that's what is the -1 oxidation state. You can exit wherever the peroxide will be there. Then one more case is there. Sir, oxygen also exhibit +1 oxidation state when attached with the fluorine atom. When it is attached with a fluorine atom, the +1 oxidation state also it can exhibit. And also you have to remember, then this can exhibit +1/2. +1/2, that is peroxide, that is superoxide case. Superoxide case, for example, KO2. So not +1/2, -1/2. KO2 case, superoxide case it is. Superoxide case, -1/2 oxidation state it can exhibit. So then, in case if you take halogen atoms, just note it all of you. Yes. The next one, rule number 6. Halogens exhibit -1 oxidation state in maximum case, 99% case. That is halogens exhibit -1 oxidation state in maximum case. But p block elements generally, the chlorine, in case if you take chlorine atom, can exhibit -1 oxidation state, 0 oxidation state, +1, +3, then +5 exhibit. So of course the +7 also it can exhibit. So you have to remember, my dear students, the p block elements, when it is exhibit the different oxidation state, we call it as a variable oxidation state. Remember that p block elements exhibit variable oxidation states. Sir, what are those that variable oxidation states for the p block elements? Sir, chlorine atom, we have seen from the chlorine atom it can exhibit -1 oxidation state to +7 oxidation state it can exhibit. So right, then in case oxygen, that is sulfur, in case if you take mainly sulfur can exhibit -2 oxidation state to +6 oxidation state it can exhibit. So nitrogen, in case if you take nitrogen, sir, -3 oxidation state to +5 oxidation state it can exhibit. So that's what I told, the variable oxidation state it can exhibit, which are p block elements. So not only the p block elements, even the d block elements also that can exhibit variable oxidation states. D block elements, for example, manganese, in case if you take, that can exhibit variable oxidation state. Chromium, in case if you take, that can exhibit variable oxidation state. Iron, in case if you take, that can exhibit variable oxidation state. So D block elements also, D block elements exhibit variable oxidation states. Variable oxidation states. For example, if you take iron, iron can exhibit +1 oxidation state, +2 oxidation state, +3 oxidation state, right? So then +4, +5, +6 also it can, +4 or then +5, then +6 also it can exhibit. Then one more chromium, even this is also +1, +2, +3, then +4, then +6 also it can exhibit. Sir, manganese it can exhibit up to +7. Manganese it can exhibit up to +7. The last final rule, that is sum of oxidation states of all atoms in a molecule is 0. In a molecule is 0. Sir, in case it is in the group of ion, the sum of oxidation states of all elements, all atoms in a group of ion is equals to charge on ion. For example, PO4 minus 3, that is sum of the oxidation state of all elements is -3. Sir, SO4 minus 2, then -2 is the oxidation state. Sir, here oxidation states of all elements in a molecule and the neutral molecule it is. For example, HNO3 is there, then sum of the oxidation states of all elements is 0. Any molecule, pH3 molecule is there, then oxidation state of sum of the elements is 0. Clear, my dear students? So in case sum of the oxidation states of all atoms in a group of ion, then the what charge is there on that charge is equals to that. Clear? So these are the rules to find out the oxidation state. So now we'll see some of the questions based on it. So by using formula, how to find out? Previous we have discussed, by structure only can give 100% oxidation state. Sir, here actually the formula generally we are discussing. Only some cases formula not work out. Sir, we are already seen which are those that are exceptional cases. Whatever the exceptional cases are there that are not satisfied by the formula. So at that time what we have to take? Only structure can give 100% oxidation state. Sir, for example, oxidation state of oxygen in one example will say, according to a formula will say, sir, H2O, in case if you take oxidation state of oxygen, in case if you want to find out, sir, that you have to take 2 plus X, it is equals to 0, hydrogen plus 1 oxidation state, then 2 hydrogens plus 2, plus X equals to 0, then X equals to -1, -2 oxidation state. So oxygen -2 oxidation state. Then CO2 carbon oxidation state. So X, then each oxygen -2, -4 oxidation state equals to 0. Then X equals to +4 oxidation state. So carbon +4 oxidation state, remember. Then next, carbon in CCl4. So now X, then each chlorine -1 oxidation state, then 4 are there, -4 equals to 0, then X equals to, then 4 +4 is the oxidation state. Plus 4 is the oxidation state. Then next, third one, look at sulfur in SO3. Sulfur in SO3 molecule, SO3, sulfur oxidation state, in case if you want to find out. Sir, X, then 3 to the minus 6, minus 2 oxidation state, minus 6 equals to 0. Then X equals to plus 6 oxidation state. Then sulfur oxidation state in H2S, sulfur oxidation state. So 2 minus X equals to 0, then X equals to, sir, plus 2. It is plus 2 plus X. Then when it is come this side, minus 2. So sulfur oxidation state is minus 2 in H2S molecule. Okay, hydrogen plus 2. Then when it is sent that side, sir, minus 2 is the oxidation state. Then nitrogen in NO3 minus, sir, X, then minus 6 equals to minus 1. I told that sum of the all ions are equals to their charge. So minus 1. So X equals to minus 1 plus 6 equals to plus 5 is the oxidation state. So nitrogen oxidation state is plus 5. Then sir, chlorine oxidation state in ClO4 minus oxidation state. So at that time, sir, chlorine X you have to take. Sir, each oxygen minus 2, 4 to the minus 8 oxidation equals to minus 1. So X equals to minus 1 plus 8 equals to plus 7 is the oxidation state. So chlorine is plus 7 oxidation state. Then one more, sir, manganese in the KMnO4, manganese in KMnO4 oxidation state of manganese. Then this is potassium plus 1 oxidation state, we know. Then manganese we have to take as X, then minus 8 equals to 0, then X equals to, then plus 8 to minus 1 equals to plus 7. Plus 7 is the oxidation state. Clear, my dear students? Right. Then come to chromium oxidation state in K2Cr2O7 oxidation state of chromium. Sir, in this, sir, potassium 2, each one plus 1, 2 potassiums are there, 2, then plus 2X, then minus 14 equals to 0, then 2X equals to, then plus 14 minus 2, 12, then X equals to 12 divided by 2, then you can get plus 6. So chromium plus 6 is the oxidation state. Okay, just note it all of you. According to the formula, you have to do like this. Yes, some more examples, look, my dear students. That is the oxidation state of sulfur in H2SO4. So sulfur oxidation state, hydrogens plus 1 oxidation state. So plus 2 hydrogens are there, 2 into plus 1 plus 2, then plus X, then minus 4 to the 8, then equals to 0. Enduk sir minus 8 తీసుకున్నాం? Each oxygen minus 2 into 4 minus 8, right? X equals to plus 8 to minus 2, then you can get X equals to plus 6 oxidation state. Then oxidation state of phosphorus in PH3 molecule, then H3PO4 molecule, then H3PO3 molecule, then H3PO2 molecule if you take. So look at from here. Sir, phosphorus you want to find out, plus X plus 3 equals to 0. Then X equals to minus 3 oxidation state for this, minus 3 oxidation state. Clear, my dear students? Then H3PO4 in case if you take, then 3 hydrogen atoms, 3 plus X, then minus 4 to the 8, then equals to 0. X equals to 8 minus 3, then plus 5 oxidation state you can get. This is plus 5 oxidation state. Come to H3PO3 minus, sir, plus 3 oxidation state, plus X, then minus 6 equals to 0, then x equals to, then minus 6 plus 6 అవుతుంది, plus 3 minus 3 అవుతుంది, then x equals to plus 3 oxidation state. So here plus 3, then in case if you take here, then 3 hydrogen atoms 3, then plus x minus 4 equals to 0, then x equals to plus 4 minus 3 equals to plus 1. So plus 1 oxidation state for this. So that's what I told. Phosphorus can exhibit different oxidation states that we are calling variable oxidation states. It can exhibit. So now all these we can do by using the formula. Formula use chesi manam find out cheyochu by taking support of the rules in this. But some exceptional cases are there. Sir, what are those that exceptional cases that we'll discuss again? By using formula, we cannot get the oxidation states of that particular compounds. For example, in case if you take oxidation state of sulfur in H2S4O6. H2S4O6. This is the molecule. Look, my dear students, according to the formula, in case if you take 2H, so plus 1 into 2 plus 2 plus 4x, then minus each oxygen minus 2. So then 2 into 6, 12, then equals to 0. 4x equals to 12 minus 2, then you can get 10. Then 4x equals to 10, then x equals to 10 by 4, that is equals to 5 by 2. Sir, 5 by 2 is the average oxidation state, but not exact oxidation state of sulfur, right? So sulfur oxidation state, in case if you want to find out, you must know the structure of this compound. Structure only can give 100% oxidation state. What I told? Structure only can give 100% correct oxidation state. Correct oxidation state. That's what I told, my dear students. So structure enti? Sir, S bond, S bond, S bond, S, then double bond O, then double bond O, then bond OH. Already we have seen this is, right? Double bond O, bond O, bond H, like this. So here minus 2 oxidation state, plus 2, then minus 2, plus 2, then minus 1, plus 1, then totally plus 5. Then here 0, 0, then here also plus 5. So plus 5, then 0, then 0, then plus 5 oxidation state. I told average oxidation state ela find out cheyali. So total oxidation states of all the elements plus 5, 0, 0, plus 5, then divided by total number of atoms are 4. So 10 divided by 4, then 5 divided by 2. So that's what the average oxidation state you can get by using the formula. But actual oxidation states of sulfur atoms are plus 5, 0, 0, plus 5 oxidation states you can get. Clear, my dear students? Right. Then one more example, in case if we take oxidation state of chromium in CrO5 will be there. Sir, x minus 10, it is equals to 0, x equals to plus 10 you can get. Sir, plus 10, chala mandi chesaru. Sir, plus 10 vachindi sir oxidation state. No, highest oxidation state entire the periodic table is plus 8 only. That is, osmium can exhibit plus 8 oxidation state, right? So that's what I told. Oxidation state plus 10 wrong. This is wrong. So what you have to know? Structure only can give, these are the exceptional cases, structure only can give 100% oxidation state. At this time formulas are not working. So minus 1 oxidation, ikkada చూడండి, ఇది ఎలా చేసాం? ఇది ఏ కాన్సెప్ట్ మీద బేస్ చేసుకొని చేసాం? సరే, రెండు ఆటమ్స్ కోవలెంట్ బాండ్తో బైండ్ అయి ఉన్నప్పుడు మోర్ ఎలక్ట్రోనెగటివ్ ఆటమ్ మైనస్ 1 ఆక్సిడేషన్ స్టేటు, లెస్ ఎలక్ట్రోనెగటివ్ ఆటమ్ ప్లస్ 1 ఆక్సిడేషన్ స్టేటు అని తీసుకోవాలి. Clear, my dear students? Right? So now, in case if you take, so look at here, oxygen minus 2 oxidation state, chromium chromium plus 2 oxidation state. Sir, here minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. So totally chromium plus 6 oxidation state. So that's what I told. Structure only can give 100% oxidation state. So structure istundi. So వీటికి exceptional cases. So ఇవి exact గా by using this formula we cannot find out. Understand, my dear students? Yes, some more exceptional cases we'll see. So note it all of you. So calculate oxidation state of bromine in Br3O8, like this is given. Sir, according to formula, in case if you take, then 3x minus 16 equals to 0, then x equals to 16 divided by 3, that you can get the answer. So this is actually average oxidation state. It is average oxidation state. But exact bromine oxidation state you can find out by using the structure only, I told. In the previous only we are discussed bromine, then bromine, then bromine, then double bond O, then double bond O, then double bond O, so double bond O, double bond O, double bond O, double bond O, then double bond O, like this. Sir, మీకు డౌట్ రావచ్చు, సార్ స్ట్రక్చర్ మనకు ఎలా తెలుస్తుంది? ఎక్సెప్షనల్ కేసెస్ కి స్ట్రక్చర్ మీరు గుర్తుపెట్టుకోవాల్సిందే. So you must be remember that what are the exceptional cases are there. You must be remember the structure. Minus 2, minus 2, minus 2. So plus 6 about it. Clear? Minus 2, minus 2, plus 4 for the middle bromine. Minus 2, minus 2, minus 2, plus 6 for the last. So plus 6, then plus 4, then plus 6. So this is the oxidation state, average oxidation state. So total divided by 3 atoms. Total 16 divided by 3 atoms. Clear? Right. Then oxidation state of iron Fe in FeO, then Fe2O3, then Fe3O4, like this is there. So look, my dear students, sir, here direct you can find out by using the formula x minus 2 equals to 0, then x equals to plus 2 oxidation state. Yes, exactly, here plus 2 oxidation state. Then if you come to there Fe2O3, even here also 2x minus 6 equals to 0, then x equals to 6 by 2, then you can get plus 3 is the oxidation state. For this, plus 3 is the oxidation state. If you come to there, if you use the formula, then 3x minus 8 equals to 0, then x equals to 8 divided by 3. So this you can get. But it is not exact oxidation state of iron, right? That is average oxidation state of iron. So exact oxidation state of iron, in case if you want to get from this. So remember, my dear students, Fe3O4, it is a combination of FeO and Fe2O3 రెండు కలిసి ఉంటుంది మిక్స్ అయింది. We are already find out FeO లో plus 2 oxidation state. So this is plus 2 oxidation state. In this plus 3 oxidation state. రెండు combined ఉంటుంది. So that's what I told. So this is the oxidation state of both. So here plus 3 for the two atoms are plus 3 plus 3. రెండు atoms కి plus 3 plus 3. So average oxidation state find out చేస్తే plus 3 plus 3 plus 6, then plus 2 plus 8 divided by 3 plus 8 divided by 3. That is average oxidation state we can find out. But exact oxidation state structure ni చూసి find out చేయొచ్చు. Okay, the same case will be there. The same case will be there in another molecule. All of you noted? Yes, we'll go. Oxidation state of lead. oxidation state of PbO, then Pb2O3, then Pb3O4. So look at. So then oxidation state x minus 2, then x equals to plus 2, then plus 2 oxidation state for this. Then what about this? Then 2x minus 3 to the 6, then x equals to 6 by 2, then you can get plus 3 oxidation state. Then what about this? What about this? So this, in case if you use by using this formula, 3x minus 8 equals to 0, then x equals to 8 divided by 3, you can get average oxidation state. Same like Fe3O4, right? So now at that time I told that Pb3O4 will be there, means it is the combination of PbO and Pb2O3 రెండు కలిసి ఉన్నాయి ఇందులో మనకి. సో దీనికి +2 ఆక్సిడేషన్ స్టేట్, ఇందులో రెండు ఆటమ్స్ కి +3, then +3 ఆక్సిడేషన్ స్టేట్. So that's what I told, average oxidation state +2 +3 +3 +8 divided by 3. Clear, my dear students? Understand all of you? Then in case if you take sulfur in Carous acid, we are seeing Carous acid, H2SO5, Carous acid. Sulfur oxidation state in Carous acid. What is the Carous acid, man? H2SO5, right? So H2SO5, according to the equation formula, if you take, then 2 plus x minus 10 equals to 0, then x equals to 10 minus 2, then x equals to plus 8 oxidation state also. But sulfur oxidation state, I told that sulfur oxidation state group number కంటే ఎక్కువ ఉండకూడదు. గ్రూప్ నెంబర్ ఎంత? +6 కంటే ఎక్కువ ఉండకూడదు. 6 + 6 కంటే ఎక్కువ ఉండకూడదు. ఇక్కడ +8 వచ్చింది. సో ఆక్సిడేషన్ స్టేట్ ఇది రాంగ్ అవుతుంది. క్లియర్? సో మరి ఏం చేయాలి సార్ అంటే, సార్ ఇలాంటప్పుడు సార్ డెఫినెట్గా యూ మస్ట్ బి నో దట్, యూ రిమెంబర్ దట్ వన్ పెరాక్సైడ్ బాండ్ ఈస్ దేర్ ఇన్సైడ్ ద మాలిక్యూల్. వన్ పెరాక్సైడ్ బాండ్ ఈస్ దేర్. సో ఒక పెరాక్సైడ్ బాండ్ అంటే, పెరాక్సైడ్ బాండ్ ఎలా ఉంటుంది? బాండ్ ఓ బాండ్ ఓ బాండ్, దిస్ ఈజ్ పెరాక్సైడ్ బాండ్. సరే ఇక్కడ -1 ఆక్సిడేషన్ స్టేట్, ఇక్కడ -1 ఆక్సిడేషన్ స్టేట్ ఉంటుంది. అంటే ఇందులో ఉన్న 5 ఆక్సిజన్ ఆటమ్స్కి 3 ఆక్సిజన్ ఆటమ్స్కి -2 తీసుకోవాలి, రిమైనింగ్ 2 ఆక్సిజన్ ఆటమ్స్కి -1 తీసుకోవాలి. సో ఎలా ఫైండ్ అవుట్ చేయాలి? బై యూజింగ్ ద సేమ్ ఫార్ములా. లుక్ ఎట్. సో 2 హైడ్రోజన్ ఆటమ్స్ 2 plus sulfur x, then what I told, plus 3 oxygen atoms ki -2 తీసుకోండి, plus 2 oxygen atoms ki -1 తీసుకోండి, then equals to 0. Then 2 plus x minus 6, then minus, what is there, 2, then equals to 0. Then x equals to, sir, +8, then -2, then x equals to +6. Now we got it as a exact oxidation state. So నీకు ఆక్సిడేషన్ స్టేట్ దాని గ్రూప్ నెంబర్ కంటే ఎక్కువ వస్తూ ఉంది అంటే దాంట్లో పెరాక్సైడ్ బాండ్ ఉంటుంది. పెరాక్సైడ్ బాండ్ అంటే 2 ఆక్సిజన్ ఆటమ్స్కి -1 ఆక్సిడేషన్ స్టేట్ తీసుకోవాలి. ఫర్ ఎగ్జాంపుల్ వన్ మోర్, నైట్రోజన్ ఆక్సిడేషన్ స్టేట్ ఇన్ HNO4 like this is given. Sir, according to formula, in case if you take 1 plus x minus 8 equals to 0, then x equals to, you can get it is +7. So +7 oxidation state is impossible for the nitrogen because group number for the nitrogen atom is 5 only. So 5 కంటే ఎక్కువ రాకూడదు ఆక్సిడేషన్ స్టేట్. +7 వచ్చింది, రాంగ్. So at that time what I told, sir, maybe you have to expect that is peroxide will be there in it. పెరాక్సైడ్ ఉన్నప్పుడు 2 ఆక్సిజన్ ఆటమ్స్కి -1 తీసుకోవాలి అని. సరే ఇప్పుడు ఇదే ఫార్ములా దీన్ని ఇందులో యూజ్ చేస్తాము. సరే హైడ్రోజన్ ఆటమ్ 1 ప్లస్ నైట్రోజన్ ఎక్స్, దెన్ ఇందు 4లో 2 ఆర్ -2, then remaining 2 are minus 1 equals to 0. Then 1 plus x minus 4, then minus 2 equals to 0, then x equals to plus 5 you can get. So plus 5 is the exact answer for this. So ila highest oxidation state meeku vastu unnappudu, sir అందులో sir you must be understand that, so it is wrong. So now in case if you take chromium oxidation state in CrO5 will be there. Sir, according to formula cheste, sir x minus 10 you can get from this x equals to plus 10. Plus 10 ante sir impossible, right? So chromium highest oxidation state plus 6. So plus 6 రావాలి అంటే యాక్చువల్గా ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఒకటి మనం ఏం చెప్పాము, ఒకటి పెరాక్సైడ్ బాండ్ ఉంది, 1 పెరాక్సైడ్ అని ఎక్స్పెక్ట్ చేసుకోం. 1 పెరాక్సైడ్ ఉంటే 2 ఆక్సిజన్ ఆటమ్స్కి -1 ఆక్సిడేషన్ స్టేట్ తీసుకోండి. సో ఇప్పుడు ఇదే మాలిక్యూల్లో తీసుకుంటున్నా, దెన్ ఎక్స్ ప్లస్ 3 ఆక్సిజన్ ఆటమ్స్ -2 ప్లస్ 2 ఆక్సిజన్ ఆటమ్స్ -1 ఈక్వల్స్ టు 0. Then x minus 6 minus 2 equals to 0. Then x you can get it is plus 8 again. So plus 8 kuda wrong antunna, plus 8 also wrong, plus 10 also wrong, plus 8 also wrong. So మరి 1 peroxide కాదు 2 peroxides ఉన్నాయని అర్థం చేసుకోవాలి. సో 2 peroxides are there, 2 peroxides. సో peroxides 2 ఉంటే అప్పుడు 4 ఆక్సిజన్ ఆటమ్స్ -1 అవుతుంది. సో 4 ఆక్సిజన్ ఆటమ్స్ -1 తీసుకుంటే సరే ఎక్స్ ప్లస్ 4 ఇంటూ -1 then plus 1 into -2 equals to 0. Then now we can get it is x equals to plus 6 is the oxidation state. This is correct. Understand my dear students? So formula యూజ్ చేసినప్పుడు నీకు అది కరెక్టా కాదా అర్థం అవ్వాలి అంటే ఆ సెంట్రల్ ఆటమ్ ఏదైతే ఆక్సిడేషన్ స్టేట్ ఫైండ్ అవుట్ చేస్తా ఉన్నామో దాని ఆక్సిడేషన్ స్టేట్ గ్రూప్ నంబర్ కంటే ఎక్కువ ఉండకూడదు, ఎక్కువ ఉంటే పెరాక్సైడ్ ఉన్నట్టు లెక్క. సో అలా తీసుకొని అది చేయాలి. సో ఆల్ దీస్ ఎక్సెప్షనల్స్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్ మై డియర్ స్టూడెంట్స్. సో మనం స్ట్రక్చర్ అయితేనే కరెక్ట్గా ఆక్సిడేషన్ స్టేట్ ఫైండ్ అవుట్ చేయగలం కాబట్టి సో యూ మస్ట్ బీ నో ఆల్ దీస్ ఎగ్జాంపుల్స్ వాట్ ఎవర్ వీఆర్ డిస్కస్సింగ్ నౌ. Okay, clear my dear students? So very very important, which are bleaching powder, CrO5, then HNO4, HSO5, all these are very very important. Please subscribe my channel and follow my channel. Then share those are preparing for the JEE mains and NEET examinations in other colleges, those are preparing. So tell them subscribe this channel. Thank you.